Calc class, late night session, take 2 here. First one cut me off after a minute, so we got a little bit of writing down already. Okay, so we get to these problems where they kind of have the box up top with all these different numbers in it, and that's typically a Riemann sum style of question. They give you some blah blah backstory about whatever. Here, someone's jogging, they give you velocity, and they give you the time intervals, or like different velocities that she is running at these time intervals. So the first one wants you to find the derivative, 16, which always just so happens to be directly in between two of these. So we can just find the slope, change in y over change in x. The biggest mistake here is knowing what goes where. Velocity is what we're taking the derivative of, so that has to be up top, and change in time is at the bottom. You go through this for 5, and that is worth 1 point there. Great. Next, they want us to use correct units and explain what the definite integral 0 to 40 of the absolute value of velocity of t is in the context of this problem. So let's start off by actually writing down what that even means. So let's do that up here in this little space. So that is going to be, notice absolute value, and we have that negative sign in there. So that is going to be the total distance traveled by Joanna from 0 to 40 seconds. Great. So now they want us to then use a right Riemann sum. So that means we're going to have all these intervals. And since it is a right Riemann sum, we want to look at the right number in all of these. So 12, 20, 24, and 40. We also then have to identify how far apart they are. So I'll do that right now. Distance of 12, 8, 4, and 16 is what we have here. So now all that's left to do is actually find out what these are. And we just got to do a little multiplication here. So we need 12 times 200 plus 8 times 240 plus 4 times 220. Notice it's a positive 220 because the question is still absolute value. And then finally, plus 16 times, what do we have here? 150. And we have to go through and add all of this up. Normally, there's no calculator, so you got to sit through and grind through this. But on RAP, there will be for all of it. So this is, you just tappa into your calculator, and you should end up with 7,600. And it is meters, but I don't think they care about units here. So 1 for proper explanation, 1 for the right setup, and 1 for solving here. Great, so that's a 3-pointer right there. Part C kind of is completely different now. Doesn't have anything to do with the chart anymore. I'm talking about Bob riding his bicycle along the same path for 10 seconds. And they give us some equation for that. And they want to find Bob's acceleration at the time t equals 5. So since we have a velocity equation, we need to think, well, how do we get from velocity and get to acceleration? And that would be, let's take the derivative here. So the derivative is going to be 3t squared minus 12t. And they want this at time 5. So plug in a 5 here. That's 3 times 25 minus, this is going to be a 60, 12 times 5. So 75 minus 60 should be getting us 15. And the unit here is meters per minute squared. Yet again, I don't think they care. Yeah, I don't think so. Point breakdown here. 1 point for a proper derivative, 1 point for the numeric answer. And then finally on to D. Based on your model B from part C, find his average velocity during the time interval. This is one of the sections they cut, so I don't think they'd ask a question like this, but we'll talk about it anyway. So they want the average velocity, so that means we have to add up all the velocities, which would be an integral from 0 to 10. So that would be the integral. And since it says average, how you find the average of something is you would add them all up and divide by how many. In this case, there's 10. So you just put a 1/10 in front and go through and solve this. Yet again, I think since they said they're cutting this, this isn't a question they could ask us. But fairly simple integral here. What do we have here? 2t to the third plus 300t from 0 to 10. 1/10 is there. We just put 10 in everything here. And go through a bunch of, yet again, just arithmetic here. You're subtracting 0 afterwards, and that would be 350, and the unit is meters per minute. Still don't care about that. This was a 3-pointer, one for a good integral, one for a good antiderivative, and one for our answer. Great. So not too bad of a question. The only thing that won't be asked on ours, yet again, is part D. Flipping over here, this is a differential equation one. In fact, this is one we've already talked about, so hopefully it wasn't too much of an issue. If you are uncertain, this was in a video I posted on April 7th. So you can go back and see me go through it there. I'm not going to take the time to go through it again here. 5. Yet again, hopefully you're looking at these questions and you're able to identify what type of question it is. It says right here, graph of f prime. So this is also a very common question that they really love to hammer year after year, that they give you the derivative equation, and you have to go from there. And they tell us it is a twice differentiable function, which means we could take another derivative. They give us some info here, horizontal tangents, kind of where you would assume they would be, but they're just clarifying that it is there. The areas of the regions bounded from -2 to 1 and 1 to 4 are 9, so this area is 9, and this one is 12, if you're wondering what they are, which means it'll pop up later. Find all the x-coordinates at which f has a relative maximum. Okay, so if we're looking for a relative max, that means we want to go from increasing to decreasing for our derivative. But since we already have the derivative here, that means we want from some positive to a negative. And where in the graph does it go from positive to negative? That only happens here, right? Positive number to a negative number. So that is going to give us an answer of x equals -2. I believe this is a 2-pointer. One for the answer, one for the reason. And I would write out a full sentence, not just be as brief as that. Say you actually want the graph to go from a positive to a negative, which only occurs at x equals -2. And that would be good. On what open intervals on the graph is f both concave down and decreasing? So decreasing is the easier one to find here. Decreasing is where it is in fact negative. So it's decreasing from -2 to 1, as well as 1 to 4. And I messed this up. This should be parentheses, not brackets, because it doesn't include those numbers since it is 0 at those points. So that's where it's decreasing, but we also want concave down. Remember, concave down is where the graph of the derivative is actually physically going down. That occurs on this interval here and here, right? Those are the ones actually decreasing. And it's under the graph, so that's going to be our answer here for part B. So part B, what is that? -2 to -1, as well as 1, 2, 3. And they do look for reasoning, so you have to say the graph is negative. and the graph of f prime, I guess, is negative and has a decreasing slope, negative slope, however you want to phrase it. And that's a 2-pointer as well, one for your intervals correctly and one for your reasoning. On to C. Find the x-coordinate of all the points of inflection of the graph of f. So remember, points of inflection would be where the second derivative equals 0. Since we have the first derivative, that would be where it changes. So our f prime from increasing to decreasing, or decreasing to increasing. And those are obviously, just look at them, they actually gave it to us already, saying that those are the horizontal tangent lines. So our answer here would be x equals -1, 1, and 3. And another 2-pointer here, one for reasoning, one for the correct full answer. On to the last one. So given that f of 1 equals 3, write an expression for f of x that involves an integral. Find f of 4 and f of -2. So it wants a specific expression. I think personally that's the hardest part for me to kind of grasp. So I'm going to do these other parts and then explain where they're getting this from and how it goes, because I think intuitively it makes more sense this way. So since they give us a specific point and they want these, that's a nice indicator that we are looking for an integral of the graph of the derivative here. And this would get us f of 4 minus f of 1. And we know that the area under the curve here is 12. And they just told us that f of 1 is 3. So f of 4 is 15. Did I mess that up? Oh, I did mess that up. So it is not 15. And this is the cardinal sin. It's underneath the graph. So although that area is 12, that is a -1 there. So we're adding that 3 over, and that's going to get us a -9. Like something seemed off. Okay, we can play the same exact game, except now we'd be going from -2 to 1. And that is f of 1 minus f of -2. We know this area, not going to get tricked here, is a -9 because it's underneath the graph. We know f of 1 is 3. And we don't know that one. Solving for f of -2, that's going to be 12. So that's 2 points there, but we didn't do the first thing they asked for. And that's solve an integral expression specifically for f of x. And since this is kind of a starting point that we have at 3, we can then set up an integral like this. And I'll talk through why this is the answer. A dx there. So we know at 1, if you plug in 1 here, it's an integral from 1 to 1, which doesn't go anywhere. So that is 0, and we still get the 3. When you kind of include any other numbers, for instance, if you had put 4 in here, we know that's the integral from 1 to 4, which we have already said is -12, so we get 3 minus 12, which gets us -9. And if you're saying, well, how would you know to do this? This is the way these integrals are set up. A lot of times in these questions, they give you kind of these, it's not technically a defined definite integral because the x is there. And you're just going to use your starting point and put the x there and put your starting value out here is how these are going to work. And 3 points here, 1, 2, 3, bringing our total to 9. On to the last one. Looking at this, initially, your eyes may be drawn right to this derivative that's given here. And you might say, ooh, I know what kind of question this is. This is one of those differential equation ones. But it's not quite the same if you look through it. They do want a tangent line. But this question is different. And then they ask for that. So it's a little bit off from what we normally have. But there are two important pieces of information they give us here. An equation and its derivative. Notice the derivative here is implicitly written because there's no nice way to solve for y here and have y by itself. So if they want a tangent line to the curve, remember tangent lines, we need two things. We need a point and we need a slope. Nice enough to give us the point. They gave us the slope equation, so all we have to really do here is evaluate at -1, 1. So that's derivative, evaluate at -1, 1. So 1 is our y, 3 plus 1, 1/4. So now we just plug it into our equation here. So that would be y minus 1 equals 1/4 x plus 1, and that's a great answer. You could add that 1 over, and that would be fine as well. But 1 point for finding the slope here, 1 point for writing out the tangent line correctly. Okay, this one's a little different. Find the coordinates of all points on the curve, which the tangent line to the curve at that point is vertical. So when are we going to have vertical tangent lines? What's happening there? We know horizontal is when it's equal to 0, this derivative. But if we're looking for vertical, that's kind of the exact opposite. That's going to happen here when the denominator is equal to 0, meaning it's an undefined function because that's a vertical line that's going straight up and down. So solving this only happens, that was meant to be equal to 0. And now I can write my arrow. This only happens when 3y squared is equal to x. And you may be stuck here and say, well, there's an infinite number of numbers that work for when 3y squared equals x, which is true. However, remember in the context of this question, we were only given two pieces of information. The slope and then the function it came from. And since x equals 3y squared, we can actually insert that in for x. Solving this, y cubed minus 3y cubed equals 2. Y cubed equals -1. And what is that going to be? Solving for the cube root of -1. This is not undefined. That can happen, and that happens when y equals -1. Okay, but it wanted the coordinate of all points. So if y equals -1, let's plug that back into our equation that they had up here. So -1 cubed is going to get us a -1 still. Plus x equals 2. X equals 3. And this is the only value that's working for this. Nothing else pops out. So 3, -1 is in fact the only point where this is going to happen. So you get a point for setting this equal to 0, which I almost botched right away. You get a point for substituting this into here. So just this equation gets you a point as well. And then finally you get a point for the final solution here. Okay, on to C. And you may be asking, what does this whole crazy thing mean? Remembering back to differential equations. With the 2 there, that means we need to take the derivative of the derivative, right? We need to take d dx of dy dx. So we need to take the derivative with respect to x of this fraction. And this one can look a little gross in going through it, because not only do we need implicit differentiation, but we also have a quotient rule going on here. So we need our fig minus gif over g squared. So the first thing we're hitting is we need the derivative of y. There's our fig. Minus, we need our gif, so derivative here of the denominator. This is 6y dy over dx, because of that chain rule in there, becomes 6y, but the derivatives with respect to x. minus 1. Great, that line's getting right in the way. And then we still need the y here. Make sure you parentheses the whole thing. It's all getting subtracted. All over g squared. So big ugly thing here, no doubt. And you may be saying, well, what's dy dx? This is a classic problem that they love to put in here because we know what that is from up here. So substituting that back in. Almost there. What am I blanking on here? Okay. The nice thing here is this first term can just become a y minus all of this. And at this point, there's no real good way to go through this except to actually evaluate here. So we can say that the second derivative evaluated at -1, 1. And then you just put all these numbers in and see what it's going to get us. 1 minus 6 times 1 times 1 over, what is this, 4th. We already did 1 and -1, right? We saw that was 1/4. Great. Minus 1, and y is still 1. All over, this whole thing becomes 4 squared, so 16. Simplifying a lot of this. This is 1 minus 1/2 over 16, so that's a half over 16. On the screen is nice, which is 1 over 32. Good, I didn't mess that up. A lot of points here. 2 points for just doing the correct implicit differentiation, so 2 points for getting here. 1 point for the substitution back in, and then 1 for that final numerical answer. Okay, let's talk homework. Man, I'm just saying that. So, homework here, we're still plugging along. 2016, let's do 3, 4, and 6. I will post these sometime on Friday, and there's been some AP updates that I will get to you as well. I'll probably send those out in a talking points. Okay, stay safe, guys. I'll post another video soon. Bye.